Flat Earth Debate live. I'm your host, Nathan Oakley, and if you are new to this channel, or you've not done so already, then be sure to subscribe. Hit the bell notification icon and join button if you'd like to become a Nathan Oakley 1980 channel member and keep up to date with the Flat Earth Debate. If you'd like to support the channel, there is a super chat that runs alongside each of these shows while they are live, and there's also a Ko-Fi, Patreon, crypto and thanks button in the info box below the video. Most importantly, if you'd like to join the discussion, simply mute the page you are currently watching, then click the link in the info box below this video to join the panel and express your views on the nature of Earth. If you do join, please don't swear. If you do, you'll be ejected, and if you are, please don't try to rejoin the stream using sock accounts. You'll be warmly welcome back on the next stream. Please also share the show on social media. Sharing the show obviously increases the live audience, but this in turn increases the chances of a more diverse panel, so please share the show on Facebook and X. Now we are joined by, in no particular order, Brian's Logic, Neil, Refracted Curvature, and a whole bunch of people in the Flat Earth Debate Discord server. So welcome, one and all.
How are you?
Thank you.
Greetings.
Neil,
Good morning, good
before the end of
morning.
my intro.
Yeah, good afternoon.
Good afternoon, good to have you. Everybody been well?
Hey, everyone.
Yes, Nathan, we're
Yeah.
all really keen. Oh, well, that's good
Yeah.
to hear.
We missed you
Well,
yesterday.
yesterday you had a bank holiday, right?
That's right. That's it. My wife had her friend over with her twins. So, yeah, there was just too much chaos here. Go on.
And it was Memorial Day for us. So
Okay.
I find that weird.
Why?
Bank holiday, Memorial Day. That's keep in mind what people done as they went to war, like war pigs getting killed for these bankers and their wars. Just a little strange to me.
Alrighty. Should we do a bit of housekeeping?
Sure, yeah.
Any evidence that you can acquire an elevation angle measurement from a curved adjacent?
No. What does that even mean?
It means, can you have a curved line in a triangle that needs a 90?
Well, the whole purpose of an elevation angle is to measure a vertical angular height to something or off something. So it's to or off something in a vertical. So how can you not have a horizontal plane?
You can't.
What's that vertical going to meet? It can't meet the curve.
You can't. It's a prerequisite. I know you were asking rhetorically.
Well, I got my son to agree yesterday. I did the thing you did, Nathan, with the light in the room and all the stars. And he agrees that everything you have to measure is from a flat plane, of course. But then he said to me, but that's only half the sphere. I'm like, what are you talking about? There's no sphere involved. He was just really
That's his
frustrated.
antipodal position.
Yeah, because there's supposedly something else going on in the south.
Yeah, there's an interesting route you can take him down, and you can thank John for this. So, once he's wrapped his head around the celestial hemisphere that he's describing, he can then take an antipodal position for the south-centric positioning system that's identical and map it underneath. So you've got a flat plane with the north hemisphere, and then a flat plane antipodal underneath it with the south hemisphere. Now, a couple of times John's dropped this in, but it's pretty advanced level stuff in terms of what they're describing mathematically when they describe an eclipse for the moon. What they're actually describing is that like line that they have running across the moon when they take the mickey out of flat earthers for their version of a flat earth eclipse in a heliocentric orbital motion. Well, in reality, that is actually what is described from a flat plane to each hemisphere wrapped antipodally. We have a common name for it too. We're all familiar with it. The celestial sphere. What is the celestial sphere when you're referencing it to the ground? Well, it's two flat planes sandwiched on top of one another antipodally. So you can have this representation of the heavens spherically. Well, that little trick of mapping and modelling the world antipodally in two flat plane-centric systems with hemispherical views of parallel planes that are mapped to give you them is the basis of the heliocentric orbital motion-based system from Kepler. So to take that down an interesting path once you understand that, Neil, and I'm not expecting you to digest all of that in one sentence, or in one go, rather, that sentence in one go, to add fuel to the fire of confusion, he'll eventually get to the point where you can explain to him that that would give him a flat pizza pie in his heliocentric motion that they try and strawman us with, that is the basis of his belief in a globe. Ironically, they are the ones with the flat pizza pie, flat line eclipsing the moon, the way they describe it mathematically. Isn't that weird? And you can take him down that path now, Neil, once you've got your head around it, in terms of where he's going with his understanding, which is cute, isn't it, John?
Well, what's actually happening is what's actually happening is to detail the solar eclipse on a globe, they must place you with a telescope at their equatorial plane at vernal equinox, because that removes the tilt aspect of the globe, right? Because the tilt is all based around the sun, so that removes that, and it extends the equatorial plane out into the celestial plane, and you must pre-assume that the celestials are moving, not you. Let's use the exact same thing in celestial navigation. It's not you that's moving, it's the celestial bodies. Same in astronomy. It's not you that's moving, it's celestial bodies. So it's purely flat plane, because the Babylonians were like detailing these things, well before there was any globe or heliocentrism. It's purely just a hijack of the ephemeris and the celestial dome model. I don't call it celestial sphere because that's something that they came up with. There is no celestial sphere. There's three main celestial domes. The one you'll experience north of the equator, the one you'll experience on the equator, and the one you'll experience south of the equator. That's it. If you know what I mean. We all have our own celestial dome, and it's not that the sky is a dome. It's that's how. And I showed this in my video, Nathan. That the latest one. It's purely a protractor. That's all it is. So there is no heliocentric predictions for anything happening in the sky. That doesn't happen. Everything is flat plane, stationary, and they're not predictions. They're just known cycles.
That's funny you say that about the stars moving, because that's when I finally told. He started showing me this opposite star rotation. So I said to him, I said, Jacob, are you showing me stars moving? He's like, yeah, the stars are moving. I said, what about the Earth? I thought the Earth was moving. He turned around and he said, I never said the Earth was moving. I said, then what? You're going around in circles here. What are you claiming? Are you a heliocentrist or are you a anti-global? What are you?
You've got to calm your frustration, because what you're doing is you're seeing his cognitive unwinding. So we've seen it on the show. We've seen people who will deny the rhetoric of the globe. We have a name for them, anti-flat earthers, as they attack us. Now, for your son, it's slightly different. He's attacking you. I suppose it is no different. But he's unwinding cognitively to the acceptance. And when it comes to something that he can't overcome mentally, he personally can relinquish some of these claims. Right? He's a free man. So he will, to overcome cognitive dissonance, relinquish the aspects of Earth spinning to fit within his argument. It's the beginning of the end. That's why we say share your pain. Yeah, all right, so you're going to relinquish some of the aspects of heliocentrism in order to explain this for you. Well, unfortunately, it's not your model. So, yeah, you can do that, but we'll just laugh at you because it's not the heliocentric model. It's a bit like you and your reference frames have been ruined, says Simon Dan. No, I don't have any. You need them, though, don't you? It's part of your religion that you're happy to relinquish as an anti-flat earther.
Exactly. Jacob actually just denied. What happened is he just addressed reality, and in reality, he observes the celestial bodies moving in reality. And when he was detailing it, that's how he detailed it. And then when you told him, Neil, but you're just detailing them moving, I thought they're supposed to be stationary for you. He said, I never claimed they weren't moving or whatever. It's like he's denying his own rhetoric purely because he wants to win a debate or not. You know what I mean? It's like, no, you're just addressing reality. And now that I've pointed out that you're addressing reality, you don't want to be held to account for that. That's what it is.
Ian from the chat says,
Yeah, I asked him, I said, why are you still holding on to it, Jacob? Just release it. It's not real. It's make-believe. Why would they do that? It's no purpose for them to just come up with a globe. I said, okay. Then I took him to the murder scene. You know? I don't know. He's in pain, I guess. You're right.
cognitive pain, yeah. But you obviously you're a doting father. You're going to see that and want it on your shoulders, aren't you? You don't want him in pain. He's your son.
Of course, you never want to see your children in pain, but that's the worst pain to see him in, because he's in mental pain right now.
Yeah, what are you going to do? Is it too late to adopt? Can you ship him off elsewhere?
They're not stupid enough to get shipped out. They ain't leaving.
They know a good thing when they see it. Anyway, should we have another one? Any evidence of the distance to the sun? We're getting into this. I was going to flex my intellectual knowledge in this regard, Brian, because it was one of the things you were talking about in terms of the satellites that we're going to segue into shortly. But in terms of their distance that they have to assert when they're giving you heliocentric distances, specifically 1 AU, light speed, they've all been derived from the same flat plane measurements also. So because they control the scale itself, they can also control the units of measure in the form of light speed. And therefore, both the ruler and the measurement with the ruler are under their control. They can slide it, they can extend it, they can tell you how big the scale is, they can make it shorter, they can put whatever numbers they like in. They've got control of it all. Because it was 5 years ago, maybe, a bit baffling to me how they could get their return distances from things in the sky and then claim victory because it matches what they've got. It's like, well, you're telling us how long it will take based on the distance calculation that you've extrapolated out for the distances in the first place and then ascribed light speed to it. So you've got a rubber ruler and a rubber universe. The scale that you're ascribing is only based on flat plane measurements of angles to begin with. And as long as it always back engineers into those flat plane measurements, everything will always function. And you can, like I say, ascribe anything to the scale you like. That's how they got the return distances to match. Because back in the day when Anthony first explained this to me with Huygens, and he compared it to one of the, I can't remember the name of the telescope, one of the big telescopes here in the UK, where a NASA guy comes down to explain about the return signals that they've got from radar bounce, and they can't see in his Jodrell bank. They can't see any information in the return signal, but the NASA guy says, "Oh, there it is, right at the timing we expect it." Now, there's nothing there for the guys at Jodrell bank, but they get convinced by the NASA guy. Now, that in my version of the story, it's like I'm trying to wrap my head around it 5 years, going, well, there wasn't a return where they expected it. There's the flaw in the story. No, the flaw in the story is he's only looking at that particular time because he's got control of when the time is in terms of the return signal. It's got to match with his heliocentric scaling. The fact that it's not there or not there to see is irrelevant. It just matches with heliocentric timings based on how fast light's going to travel and bounce and come back. But as I say, they've got control of every single part of this scale, structure, everything. What's it based on? Flat Earth measurements. Angles.
What they
stars.
do...
Sorry, I'm done.
Sorry, I thought you were finished, and that's why I came
I was adding an extra conclusion that where's the origin? I always want to drop it in. It's based on angled measurements to stars, isn't it? But that's the origin that I'm going to focus on, 2024 and all. Sorry, go ahead, Brian.
And if we go, well, say about it is, if you look into what came first, the distance to the sun came first before light speed. Right, the claim two-way speed of light calculation came after that, or any claims to do with a light speed being used in calculation came after that. And where did the distance to the sun come from? Came from them pre-assuming we're on a globe of radius 3959 miles, and that Venus is also a globe of similar size. And when it transited the sun, they used the angular size of Venus in relation to the angular size of the sun to determine how far we were from Venus and how far Venus was from the sun within their paradigm. And they call that a measurement. And after that, then, they could just change, like, that allowed them to, there was claims about the sun being bigger and further away before that, but not, they hadn't got the 93 million, the 90 or the 93 million, they hadn't got any of that. So the problem they have is they had to work with angular sizes, something that doesn't exist within their everyday world. The chair that you're looking at, or the car you're looking at driving away from you, that can't change an angular size within that paradigm. But the sun has an angular size, which is within that paradigm, which is completely bizarre. But that's how they did it. They just compared angular sizes after several pre-assumptions. And then they came up with a two-way speed light calculation sometime after that. Today it's called Einstein's convention. That's what it's called today. And if you look at it, it's 671 million miles per hour. That's the claimed. That's the claimed. That's the claimed speed, right, or claimed calculated speed, or whatever, right? But the thing about it is if you break that down into, just 1 second, I'll do it now. I'll break it down. If you break that down by 32, so 671, right? 671 million divided by 32 equals 20,968,750. So you're nearly at 21 million miles, right, per hour, if you broke the two-way speed of light calculation down by 32. Now, in reality, when we're using things like laser rangefinders and police speed guns, all the things we would use, radar, these kind of, or any of these types of special types of radar or whatever, all these kind of things, these return signal things. If we just use that calculation, what would be the difference in reality? It would be a fraction of a second for most of the time, wouldn't it? Nobody would notice the difference because 671 million miles per hour is such a monstrous speed that it would be, you know what I mean? Nobody would notice the difference because 21 million miles per hour is a ridiculous speed. You know what I mean? I think that breaks down as I just divide that by 60, right, and divide it again by 60, and that will mean that light would be moving. If we broke the two-way speed light calculation down by 32 times, divided it by 32 times, light would still be moving at 5,824 miles per second. Do you know what I mean? It's like, no, who's going to notice the difference? No one's going to notice the difference. You can break it down further. It's just a calculation that allows them to expand out their paradigm into a bigger and bigger vacuum, and that's all it is, really, isn't it?
Yeah. And they do have an endpoint in Einsteinian mathematics, as far as I understand it. Then there's all sorts of speculation thereafter from what's the guy who just recently died in the wheelchair, Stephen Hawking, where you've got time going backwards and things like that. Big crunch.
Yes. Yeah. Stephen Hawking's also acknowledged that Earth was a flat plane. He said the globe is a flat plane, and that is your X and Y coordinates.
As a paraplegic black lesbian, I find that highly offensive.
I'm sorry. I shouldn't have made fun of how he talked when he said that, but he did say that.
Why not? It's just a puppet. That's what I heard.
Oh, God. Right, Brian, I'm hoping you've got a presentation to take us away from this slanderous.
I have, yeah. Just give me a moment. I'm just presenting now in a second. I have to just do a little update thing with Google. A second now.
You're updating your PC while we're doing the live stream?
No. I have to just give permission for my screen to be.
Okay.
Okay, can you see my screen there?
Yes.
GeoGebra? Right.
We see your screen.
Screen. Okay, now I'm going to go through this with you. Right, to try and make some kind of help the understanding of it a bit, right? So this is how their claim works, right? Here is their globe at the center, right? This here is the orbital path of the satellite. This is always 12,550 miles away. Now, this is how it works. This is how the only way to help it to work. This is how what I'm going to show here is the only way it can work. One of two ways that it can work mathematically on a globe, right? So you have to remember, what's the claim of the GPS? The claim is that it proves a globe. But what I'm showing is that it not only requires a flat plane for everything it does, but it doesn't prove a globe. It actually does far more proves a flat Earth, right? And that's where the real problem is. Because I'm, as you said before, you're pulling back the curtain, showing them what the wizard actually is doing. So now they're left with a situation where they're allowed to believe in it, but that's all they have is a belief. They don't have any knowing. There's no like definite. If this proves a globe, it doesn't. It proves a flat Earth because they're using a flat Earth. They know a thing. But this is how it can work geometrically on a globe. So if you take this blue line here, this blue circle, this is always 12,550 miles away from the globe. That's what's called a medium globe Earth orbit. And these four other rings here, they're all connected to these four satellites. There's the blue one, the green one, the red one, and the purple one, right? Each one of them, right, the distance between the satellite and the receiver is claimed that the receiver creates a sphere around itself based off of that as a radius. So this blue line here is making this sphere here, right? And the receiver does the same with this green line here, and this red line, and this purple line. So that creates four spheres intersecting the globe, right? And those spheres will always be based on the length or the distance between the receiver and the satellite. So I'm going to use the blue one here because that, right, rather than moving them all around, I just use the blue one, right? Here is the receiver in yellow. I'll move in a bit so you can see it a bit clearer, right? Here is the satellite. It gets, the claim is officially, the receiver gets a signal, right, from a satellite, and it determines based off of the time the signal was sent and when the receiver got it, by using the two-way speed of light calculation, the receiver determines its distance from the satellite, right? Now, people might think, why is it not just using the 12,550 miles that the satellite is always from the surface of a globe? No, because where the receiver is and where the satellite is going to give a different length. So this is the only way this can work on a globe, right? This is one of two ways it can work. And they're both the same thing, basically, right? And this is one of the main things that's funny enough that the ballers have a problem with. You think they would embrace this, but no, they don't like it because it actually addresses the Earth. It has a known constant distance here from this blue dot to the satellite of 12,550 miles. It has a known distance from the center of the globe to that blue dot of 3,950 miles. So when it calculates the length of this one, right, this other serrated line here, as you can see that number changing on the screen as I move it, right? As I move that, I'm moving the satellite around in its orbit, but I'm also moving this blue dot. I'll make this a little bit bigger so you can see it, right? That is its sub point. That's the sub point, or what would be the GP point of the satellite. It would be a GP point in celestial navigation. It now has the length of this line. Sorry, this blue line here. Sorry. Just 1 second. I'm just going to take down the opacity of that or whatever, just make it easier. It now has the length of this blue line, and it has the length of this line, right? It knows the angle between this line here and this line based off of the length of both lines and the fact that they're both on a globe of radius 3,959 miles. because it knows that this one is always going to be 12,550 miles in length. So when it calculates this one, right, this line here, right, it knows from that length at what angle this would have to be in relation to this one. And to get right, and how it would determine it's the arc distance between it and the subpoint is it just needs to get a third line between it and the subpoint, making up a triangle here, and then determine the arc length based off of that chord length. That's one way, one of the ways it could work on a globe, right? Mathematically. Now we're not going to show the flat Earth part. Yeah, that'll come in a minute. That came before any of this. This is all after the fact, right?
Can I just get a thank you from me and John, because we didn't interrupt that one bit saying you'll need a flat Earth here and there, did we? I could have. I held my tongue twice. I don't know about John.
Yeah, because the flat Earth part is coming up next.
Yeah. I sensed that.
Before this.
I sensed that
on the way.
I sensed that from your preamble in terms of I haven't watched your most recent video, so I'm not really ahead of the game, but I sensed that. Carry on, Brian.
Thank you. The other way it can determine see, this is the thing. What the ballers don't like is the fact that I'm pointing out that the receiver requires the coordinates of the subpoint, which will be a GP point in celestial navigation, let's just say, but it's a subpoint they call it when it comes to GPS.
Sorry, which system? Just sorry to interrupt. What system are they using for that point?
The point here, it's what you mean? That's GPS. The subpoint.
For what you compared the subpoint, right? It's going to be on a coordinate system. Which coordinate system?
Oh, it's going to be on an XYZ coordinate system.
This is the point. Okay, fine.
Yeah.
So it's not got a name. It's just any coordinate system.
Cartesian.
Yeah.
But Cartesian coordinate.
It's not like it's going to be plotted onto any particular map. It's just going to be in a Cartesian grid at this stage.
It's going to have an XY position. See, this is the thing. I'll show you in a minute. This blue subpoint will have an XY position. The ballers keep on wanting to talk about XYZ, but they don't realize, they don't want to accept that the XY position that's actually being referenced in reality, right? They don't want to accept that it's not at the center of their globe, it's actually on the surface of Earth. And that means that the receiver's XY position is in a horizontal, more or less, if you treat XY as just, let's say, sea level, then it's because XY is two-dimensional. That means the receiver and the subpoint has to be on the same horizontal, right? That's what it means. And they don't want to deal with that. They want to deal with only a flat plane in a different way at the center.
I'm really
we'll
sorry
get to
to
that in a
interrupt. Now
second.
I'm really confused. The way you explained it 2 minutes ago was that they're getting the chord line to give them the angle, but then they're calculating the curved distance from that based on radius 3959. Yeah?
But what I'm showing here, is how the only way, one of two ways, I'm going to show two ways that it can be done geometrically using a globe after they've used a flat plane. I'm just showing, and the problem is the ballers, see this subpoint, none of our opposition except this subpoint. With the exception of one of them, I know. One of them who has looked into GPS and does know
What do you
better.
mean?
He
Hold on,
accepts
what do you mean
the subpoint.
accept? It does use a
They want
subpoint.
to.
I don't understand.
I'm trying to get to. You're not allowing me. I'm trying to explain it out to you, but you're not. Remember, I'm trying to get to the point of showing you what I mean. But
Fine.
you have to leave me go through it, and you'll understand then. See, they don't want any coordinates on the surface of Earth because they're claiming X, Y, Z coordinates. That means the XY is a horizontal plane. That means the subpoint coordinates that they are denying, that is an official part of GPS, the subpoint coordinates has to be in a horizontal with the receiver because it's two-dimensional coordinates, so they're both placed at sea level in an XY plane. They don't want to deal with that. They want the XY to be only at the center of their globe. Do you understand? Across, they want the XY plane to be here. They don't want it to be there. Do you know what I mean? They don't want that because that means that the receiver is also on this same plane. So they only want to deal with X, Y from a center point, but that doesn't help them, and that's where I'm getting to in a minute. I'm just trying to point out certain things that how the only way it can actually function on a globe. What to do? Sorry. The only way it actually can function on a globe or geometrically after you've used a flat plane. Just leave me get to it. You'll see it. When I show you the diagrams, it'll all make total sense.
Okay, let me just do a quick shout out.
Okay.
Thanks, Roger Ledwell. It says evening, morning, whichever you choose. Thank you for the super chat. Carry on, Brian.
Yeah. Okay. So the other way that they can do it is they can take this big blue sphere that's based off of the distance between the receiver and the satellite, right, as a radius, and they can determine based off of the size of that sphere and the size of the sphere that it's thinking it's on, that it's going to intersect, right, at these 2 points, right, based off the two sizes. One intersection point will be where it is, and it'll have to intersect here, right, and it'll figure that out based off of the angle to the satellite, right. That's so because they deal with angles. I'll show that in a minute, right. And then all it has to do is based off these 2 points. They don't need to know the coordinates of this. Just needs to half the length of the arc, and that where the coordinates they got for the sub point. That would be where the sub point is. That's another way it can work. It's a little bit more complicated, but it can work, right? But all this doesn't matter because this is all after the fact, right? Because I'm just going to stop sharing a second, and I'm going to share a different screen, and I'll show you. 1 second now. Where is it gone? Window. Where's my other window gone? Sorry. 1 second now. Sorry about this. Oh, I should be able to see it now. Window. Chrome tab, window. I don't know where it's gone to. 1 second. Cancel. I just go again. Should pick it up this time. Window. Right, there we are.
Yeah, that's working well. That's good.
Okay. So what I was showing there a minute ago was the globe and these 4 different satellites creating 4 different spheres based off of their distance, or well, the receiver creating 4 different spheres based off the distance between it and those satellites, right? But here they show on this diagram, this is no official diagram, they show the satellite right in the center of these, which is okay. You kind of go, well, okay, fair enough. You want to depict it that way, but you're just showing 3 circles from overhead, so that's not a globe. But then you go on to the next one, and suddenly they're showing a line to the center of these circles. What's that about? Why are they showing a line to the center of these circles? And these circles now, instead of those lines from the satellite going to the receiver, they're showing them going to what would be the subpoints of the satellite. And see these points on the ground here? These are the things the ballers don't want to address is being used by GPS. How would a receiver find its location if it doesn't have coordinates on the surface of Earth to determine its location from?
Just to drop this in here, if you look on my diagram just below yours in the Hangout, got the same exact thing for 3 circles of equal elevation when you're finding your GP as opposed to the subpoint. You need it on a flat plane. The penny dropped halfway after you told me off for interrupting constantly. But yeah, so if you've got 3 points that are matching up with your measuring point on a Cartesian grid, the XY is flat. Therefore, you can't have it cutting through a chord line and calculating curved distances when you're going to be plotting it out from the measurement point to the GP, in this instance, subpoint, flat. It's flat.
Yeah, well, that's the thing, right? That's the thing. 1 second. You see, this is the thing. They went away from the spheres that I've made here that are supposed to be based off of a distance between the receiver and the satellite. And suddenly, these dots here that I'm pointing at, these circles are based off of a distance between the receiver and these subpoints. So suddenly, the circles that are being made, they're not spherical caps anymore, because you can't have a circle on a sphere. They're now 2-dimensional circles, and they're based off of a distance between the receiver and the subpoints, not based off of an intersection of 4 spherical caps. And how does the receiver determine its distance to these places? Well, it needs 2 things, doesn't it? What does it need first? It's going to need azimuth, right? Another thing the boaters are denying, and I don't know how many photos are showing that GPS receivers have compasses in them. They're called microsensor compasses. And they work with the magnetic field. They're a MEMS compass of some kind. They work with the magnetic field, and they're using magnetic north, right? And that gives them, right? What happens is that the receiver gets the azimuth of, let's say, this blue, or this green dot here, right? The azimuth of that, which will equal the azimuth of, let's say, the satellite. We just use the satellites. I know they're nonsense, but we just use them for the moment, right? The same for the blue dot, the black dot, and the orange dot, right? So it knows, based off of its compass, what direction in relation to north they're in. So if north is here, and the receiver is getting a signal to say the blue dot is southeast, it knows that the blue dot is southeast. So it's going to make the azimuth from north around the southeast, right? That's what it's going to do, east to west. That's how azimuth works. Then what's it going to need? It's going to need elevation, isn't it? Right? And it has to know that what's known as the mask angle. The ballers also denied that GPS uses an angle. It needs to know the mask angle, because just like with celestial navigation, GPS tries not to deal with anything below 10 degrees, 10, 15 degrees. Most, right? Depends on the receiver, but they try not to deal with anything that's below 10, 15 degrees. And this is the official claim, right? Now, they don't need to deal with anything below. They're still dealing with a flat plane, right? And flat plane coordinates after this, right? With the way I actually show how it works, right? In my own video on how it works. But even within this, I can make this work easy on a flat plane. I can make it work on a globe, but it's more complicated, and I must start with a flat plane.
What do you mean you can make it work on a flat plane? It is a flat plane.
Yeah, but that's my point. GPS was claimed to prove a globe, but they need azimuth and elevation, which is the horizontal coordinate system. Here they're showing a 45-degree angle to this satellite. The receiver will use the signal from this one, but it won't use the receiver from this one over here because it's below 10 degrees. How does it know what 10 degrees is? Because it knows what angles are. Why does it have a compass? Because it needs to know what azimuth is. What's azimuth and elevation? Azimuth is flat plane coordinates from north around east, south, and back around west. What's elevation? It's an elevated angular vertical height above horizontal plane. That's what it's doing. And it then uses triangles. If it knows it has a 45-degree angle to whatever, and you know what I mean, it knows directly below the satellite is the sub point. It's then using that angle, the triangle it makes, to find the sub point. Now, I show what I say in my other video on how I show it works. I think that's how it's actually working, not what they say here, because what they say here would mean that the actual distances would have to be different in different things within their calculations. But the point is, they have to start with azimuth and elevation. And after that, they can start calculating in a globe, but they can't do anything without that. And this is the problem. The ballers can't handle this, because this means the ballers want this to be the center of their globe. It's not. That angle, see this point here, that 45 degrees point, where it's meeting the edge of this dome here. That is, well, remember I said earlier about them not wanting to deal with the sub point. That is for them the sub point on their globe. And they don't want to deal with that coordinate, with the coordinates matching the sub point, because they want the coordinates only to come from the center of their globe, the equatorial plane of their globe, and they don't want to deal with an XY coordinates on their surface, because that means there's 4 XY coordinates on their surface for the sub point of points of 4 different satellites, and there's also an XY coordinates for the receiver on the surface of the globe. And what does that make their globe? A flat plane.
Yeah.
So they don't like it.
It's bizarre. It should be really obvious. It should have been really obvious. Why did it slip us by? You know what I mean?
Exactly. That's what I'm saying. That's my point on it. It's like it. That was what I was trying to point out with the XYZ back in 2019, 18, 19, whenever it was. That it's they're using a flat plane because that's what they're dealing with. What did they survey? They survey flat planes. Everything is a flat plane, flat plane, flat plane. They're not dealing with curved anything. They're dealing with flat planes and elevations above and below that flat plane. And that's what they're doing. And in GPS, that's what they're doing. Because they're navigating reality. You're finding your way from A to B. I'll put it this way, right? This is something I've asked some of the ballers in the past, but it's a very easy question. If I'm navigating my way from where I am now, let's just say, to where you are, Nathan, right? If I'm navigating over a curve, then an airplane flying from where I am to where you are will have to account for that curve, won't it? Will it be accounting for that curve? No, because it's not there. If it was, airplanes would have to account for it. You know what I mean? It's like there's no way around it. You know, if GPS is going to address reality and get me from where I am to where you are, then it's going to have to address a flat plane with topography, because it won't need the topography part is secondary, because GPS mainly just works into 2 dimensions. It's just A to B on a map, basically, and it can give you your elevation because it has access to mapping or it has mapping installed. But your elevation is not important. It's only from where you are to where you're going. Do you know what I mean? That's what it's interested in as much of a straight line as possible. So if it's a curve between me and you, how come airplanes aren't accounting for this curve?
Well, there isn't.
Because it's not there.
Well, it isn't, and it's not dealt with that way, as you're showing. You know, you can try and wrangle it in a way that makes it seem like it's working on a globe, but it isn't. I liked how you said, it's a weird mindset. I can make this work on a flat Earth. You're like, it is a flat Earth. What are you talking about? There's nothing to make work.
Yeah, but what I meant by that is that within the official claim, I can make work on a flat Earth. Easier to can make it work on a globe within the official claim. This is the official claim on how GPS works. Whereas my own version of what I think is happening with GPS is a little bit different. I might go into that maybe tomorrow, not today, but maybe tomorrow or the next day on what I reckon is happening with GPS. Because this is okay, but this has a few flaws. But yet it works better on a flat plane than like mathematically I'm talking about. It works better on a flat plane than it will on a globe. I can make this work on a flat plane. I can find the distance to the sub point on a flat plane. Do you know what I mean? Easier than I can on a globe. I need more calculation on a globe. But I still have to start with a flat plane to even address the globe. Because remember that line that was going up to the satellite that was through its sub point from their center point? That's what this is. But now this diagram is showing just honesty. No, you're just on a flat plane. There is a thing, an angle to something above you. And it doesn't have to be above you. It can be something that's stationary at a different altitude. Or it can be an airplane. Airplanes have GPS receivers on top of them and on the bottom. On the bottom, they need, I think there's assisted GPS, which what you will get, and I will get with our phone, and there's differential GPS, which is what surveying will use, I think military use and aerospace use, and shipping will use. So what is differential GPS? It's ground stations. Assisted GPS and differential GPS are very similar in a lot of ways. They're just using ground stations. So they call them like a repeater station. That kind of way. So the plane is getting GPS information from the ground that the ground is claiming to get from the sky. You know what I mean?
Roger Legwell says the A and B satellites and screenwriters. I don't really know what he means.
No, Roger talks in kind of riddles sometimes.
Thank you for the super chat.
Yeah, but
really
why would they?
Sorry, Brian, go ahead.
I'm just saying, why would airplanes have receivers on their top and their bottom? Why would they use them? Why would they have one on the base of the man on the top, on the roof? Right? Well, the one on the roof can be used with other planes if it wants, or high altitude balloons. We don't need to have satellites, as in orbiting a globe in a heliocentric space. The one on the bottom is used with ground stations. If you're flying a plane, are you telling me that the plane can't pick up GPS from a ship that it's flying over? You know what I mean? Our opposition want to deny that this is possible. No, they're not picking. Why not? They're picking it up everywhere. And as far as I'm concerned, in the way I show how GPS works, I just don't have the time to go into that right now. That is another one. That is another 20-minute presentation, which I might do tomorrow if you're around, or the next day. I reckon they're also using celestial navigation. Why wouldn't they? GPS is basically based off of it. Why would you not use celestial navigation? It makes no sense not to use celestial navigation. So I think they're using, in my system, they're using celestial navigation, and they're using every single source they can find, every piece of information they can get on any coordinates. Why not? That's what will give you precision. That's what will help you. You know.
Oh.
I asked the question, not anything to do with this, but if you're on an airplane, are you detached from the Earth?
Yes.
Having me on, Neil. Why are you asking that?
Okay. I had Dell.
The same is true
and
for a
he's
helicopter.
saying that I don't know what I'm talking about because he's taking a piss out of Anthony's experiment because he's going against this claim that we're on a stationary Earth, that nobody ever claimed any type of non-movement. So he takes Anthony's experiment and he says if I was on a plane and I jumped out with Anthony's experiment in free fall, it would totally debunk Anthony's experiment, because once you're detached from the Earth, it don't work. I said, but wait a second, why do you even got to jump off the plane? If you're on a plane, you're detached from the Earth. He said, no, you're not.
If you change one of the control variables and you try to have two independent variables, it won't work. No, it won't, Dale. You're an idiot. You don't know what an experiment is, obviously. You're just using words. Yeah. What's held constant with...
Sorry, John, go on. Sorry, I just...
What's held constant when Anthony's doing his little relative density test there? Is he on a bus doing it? Is he in motion while he does it?
Yeah, that's the whole thing. He's claiming that once you take it out of that and go in free fall, but...
So you're no longer doing an experiment.
It only works, hold on, it only works when you're attached to the Earth. But if you're detached from the Earth, so I don't know what he's talking about. If he jumps out, he's no longer detached from the Earth. But if you're in a plane, you're detached from the Earth. He said, no, I'm an idiot, and lift. That means you're on the Earth.
Okay, let John unpack it. He's tried a couple of times.
Right. He said, what if I change something else while doing Anthony's experiment? He's trying to introduce two independent variables. Do you test two independent variables in an experiment? Is that an experiment? And if it's not an experiment, how does a non-experiment debunk an experiment?
We're dealing with it from all sides within Flat Earth, it seems. They all want to use the same magic trick that deceived everybody else, which is claiming you've got science when you haven't. I mean, I thought we'd have communicated this across to the whole Flat Earth community 5 years ago. I'm sure QE was hoping it would have been done 6 or 7 years ago when he appeared on the scene. And it's intrinsic.
Yeah, but I think Dell's getting confused. with. I thought Newton's laws of motion were not correct, right?
Yeah, well, they're not correct for on the small scale. You know what I mean? They can work pretty well on the big scale, but not on the small scale. They were debunked by quantum mechanics on the small scale because things don't adhere to them on the small scale. You know, maybe gas behavior or that kind of thing. But when the guy is jumping out of the airplane, is he going down? Because according to Dell, he's not going down.
Yeah, I said that too.
Yeah.
He said,
But
no,
see,
the Earth is rising up.
Yeah, but then in that case, weighing scales can't work. You understand?
I said that too. I said, Dell, a weighing scale debunks you. I hope he didn't go into it anymore because I don't know how I would break it down, but I just threw it in there.
Well, how do you press down on a weighing scales if you have no weight? If you've got no weight, it means you have no inertia. So an earth pushing up against you, like if an earth was coming consistently going upwards against you and you have no weight, you wouldn't even be attached to it because it'd keep on bouncing you up to it. But the point being is that if you have no weight, you have no inertia. If you have no inertia, so there's nothing for that weighing scales to press against. You understand? So it's like it's pressing against nothing.
Oh, I see what you're saying. I got it. Yeah.
So weighing scales need something to press. It needs to be pressed in two directions. Something either it can be something coming up underneath it, like you can weigh yourself. You can weigh yourself in a lift. You know, in an elevator. You can weigh yourself in an elevator, but you still will have a downward force on that scales. But within his paradigm, you can't have a downward force because you don't have weight. It's only apparent, not actual. That means you don't have inertia. That means you can't put pressure on the scales. Nothing can. If you know what I mean.
Is that a good
Well, I say next time.
It's Neil that's asking the question. I just want to know if it's been answered to his satisfaction or not.
Yes, I got it.
Next time someone asserts something about Dale debunking Anthony's experiment, I'll just assert something that's not an experiment to debunk water boiling. You know, that seems to be acceptable in this arena, right? You can say it's the shape of the container that causes water to boil.
But that's basically what he's doing, right? When he's
it's nuts. But with that, I'm going to say if you are watching this on either Nathan Oakley 1980 or Nathan Oakley premiering streams, then stay tuned as there will be an after show to follow. Unfortunately, though, if you are watching this live, this is where we bid you farewell. So, another massive thank you to today's Discord and Jupiter's panels. Of course, to you for smashing the super chat and all that good stuff. I've been Nathan Oakley, and I'll see you all in the next video.